Good morning to all. Myself Jhansi Rani Challapalli from CSC Harness Department. Today I am going to present a lecture on design and analysis of algorithm of traveling salesman problem using branch and bound technique. First of all, what is branch and bound technique? Branch and bound is one of the optimization technique. This can be used for solving minimization problems. What is minimization problem? The problem which can reduces the cost. So that is call it as minimization problem. Here why we apply branch and bound technique for this traveling salesman problem? Here there are so many optimization techniques are there, like backtracking, dynamic programming, greedy approach, divide and conquer. Among those, branch and bound technique optimizes, it reduces the number of branches while expanding the tree. In branch and bound technique, the solutions can be represented by using a state space tree. So here in state space tree, it reduces the number of branches. That's why we use branch and bound technique. Here, what is traveling salesman problem? Traveling salesman initially start at vertex, source vertex, and visit all other vertices with minimum cost and return to the source vertex. That is the given traveling salesman problem. Here the problem can be represented by using a graph. What is a graph? Here a graph is, what is a graph? Here a graph is nothing but a set of vertices and edges, where V is nothing but vertex and E is edges. So here the graph is a directed graph. What is a directed graph? Directed graph means the edges have direction. That graph is called it as directed graph. So next, what we have to do? We have to create a cost matrix for a given graph. So what is cost matrix? Cost matrix is if n cross n matrix. There is a cost values if there is an edge between I and j, where I is the one vertex and j is another vertex. If there is a cost, that cost is nothing but every edge is assigned a positive value, that is call it as cost. So if there is an edge between one vertex to another vertex, then we have to give C of ij value as edge value, otherwise we have to put infinity. Okay. So here if ij does not belongs to E, then we have to put infinity. Next, what is let? Here what is modulus of V? V is nothing but set of vertices, that is equivalent to n. What is n? Where n is the number of vertices in a given graph. Suppose if a graph consists of 5 nodes, then the size of the cost matrix is 5 cross 5. Okay. So what is the traveling salesman problem? Here we have to find the tour with minimum cost value. Okay. So initially the traveling salesperson starts at a vertex 1. So what is the solution of this problem? We have to find the shortest cost tour. Okay. Here the solutions can be represented by S. S is the solution space. Here it consists of the solutions. Here 1 is the starting vertex, R is the minimum cost, and return to the same source vertex, that is 1. Okay. Here where R is nothing but number of permutations. If there are n nodes, so we have to visit all other vertices from 2 to n. Source vertex is 1 and we have to visit all other vertices from 2 to n. So therefore how many possible combinations we can get? S into n minus 1 factorial. Next, this is an algorithm for traveling salesman problem. Okay. What is a traveling salesman problem? We have to find the minimum tour path. Here we have to first obtain the cost matrix for a given graph and then obtain the reduced cost matrix. What is reduced cost matrix? Why we reduce the cost of each head? We have to find the shortest path which has a least cost. Okay, that's why you have to define a reduced cost matrix. What is reduced cost matrix? reduced cost matrix is nothing but here every element in that matrix, every row and column must have at least one 0th element. For example, I am considering an array. Suppose it is a 3 cross 3 matrix. So we have to examine each row and each column. There must be at least one 0th element. So in the first row all elements are non-zero elements, second row also non-zero, third row also non-zero. So we have to find the minimum element in that first row, that is 1, second row that is 4, and third row that is 7. We have to sum up all these cost reduced values. 4 plus 1 5, 5 plus 7 12. So the row reduced cost is 12. So what we have to do, remove subtract this minimum element for all the elements of that associated row. Suppose here in the first row the minimum element is 1, 1 minus 1 we get 0, next 2 minus 1 1, and 3 minus 1 is 2, 4 minus 4 is 0, 4 minus 5 1, and 6 minus 4 is 2, and 7 minus 7 0, 8 minus 7 1, 9 minus 7 2. So this is called reduced cost matrix, reduced row cost matrix. This is called reduced row cost matrix. In the similar way we have to examine columns also. So and then we have to sum up the total reduced cost equal to reduced row cost plus reduced column cost, then we get the total reduced cost. So in this way we have to find the reduced cost matrix. Okay. So here in the, that is the first step. What is the first step in this algorithm? First we have to define a reduced cost matrix by applying row reduction and column reduction. What is row reduction and column reduction? Every row and column is said to be reduced if and only if it contains at least one 0 and remaining all the elements are non-negative. So that is called it as reduced cost matrix. Then go to step 2. In that step 2 what we get? We get the reduced cost matrix from the step 1. So that reduced cost matrix can be denoted with A. Let it be A. So and then we have to take a node R. What is node R? So this is the reduced cost matrix for the node R. R is called it as a root node, where R is called it as a root node. In branch and bound technique, the solutions can be represented by a tree. This is called state space tree. Okay, this is called root node. Root node it is called it as a, initially call it as a live node. What is live node? Live node means the node is generated but its children are not generated, then it is called it as live node. When that root node is expanded by generating its children, this live node becomes E node. Let it be the root node is A and the child nodes are B, C, D, E. Here A is called, what is A? A is called E node and B, C, D, E are called live nodes because they doesn't have any children. So B, C, D are called children. Here in the traveling salesman problem, the solution can be represented by this state space tree. This is called state space tree. So for each node we have to find the reduced cost matrix. So initially we find the reduced cost matrix for the node R, where let it be the R is the root node. Okay. Next we have to find its children, whether there is whether it provides a solution, we get the answer no. So we have to expand this node by finding its cost. Okay. So here what is the cost of this root node? This cost of this root node is the reduced cost amount. Let it be the reduced cost of the given cost matrix. Reduced cost matrix is let it be 25. So then the cost of this root is assigned to 25. C cap of 25 equal to C cap, which is represented as the lower bound. This is called it as a cost. The root node cost is 25. Okay, so this is assigned to this root node. So whether the salesperson visit all the cities, no, so it doesn't provide any solution. That's why we have to expand this tree. Okay, here we have to, if S be the child of R, what is S? Let it be S is the child of R such that the tree edge RS correspond to including edge I comma j in the R. Here we have to visit all other vertices. So let it be the vertices are I equal to 2, I equal to 3 and I equal to 4 and I equal to 5. So I equal to 1, this is initially the source vertex. What are the remaining other vertices the person have to visit? 2, 3 and 4. Okay, so we have to find cost for the children node. How to find the cost for the remaining children nodes? First, make all the entries in the row and ith row and jth column as infinity. So we have to put all the values of ith row and jth column as infinity. Next, second step, a of I j comma 1 value is also set to infinity. After that we get some matrix, then we have to apply reduction. So what is reduction? We have to find out row reduction and column reduction, then we get the final reduction matrix. Okay, so that is call it as matrix B. After that we have to calculate the cost of the children by using this formula C of S equal to C of R plus A of Ij. What is C of R here? C of R is the cost of the root or parent, and A of Ij is the cost of that edge in that reduced cost matrix. Okay, next, what is R? R is nothing but the reduction, total reduction. So this in using this we can find out the cost for each node, each children node, and the same process. What is that process? Do this procedure for all the remaining nodes. Okay, then we have to apply the same process for all the remaining nodes B, C, D, E. Same process is repeated. Okay, then we get matrix, different matrices and different cost values. After that we have to examine which has the least cost, only that node can be expanded. For example, the cost of this node is 28, the cost of the C node is 36 and D is 54 and C is 31. Among these four, which one is minimum? 28 is the minimum. So we have to expand this node by generating its children. So this is the least cost method. In branch and bound there are three techniques are there. One is LC and second one is FIFO BB and third one is LIFO BB. Okay, LIFO BB, LC means least cost, this is least cost approach, and second one is FIFO means first come first order, LIFO means last in first out order. So these are the three techniques that can be used in branch and bound technique. So for this scenario we are applying least cost approach. In the least cost approach we have to define a cost function. So this is call it as a cost function. Using this cost function we have to find cost for each node and then examine which one is minimum, only that node can be expanded. So automatically it reduces the number of branches and also it reduces the computational time. So that's why we use this branch and bound for this technique. Okay, next. So that is the algorithm for branch and bound technique using LC approach for traveling salesman problem. So here we are considering one example for implementing this algorithm. So initially we have to take a matrix. What is this matrix? This is called adjacent matrix. For a given graph, we have to construct a adjacency matrix or cost matrix, also call it as cost matrix. Okay. In the graph there are 5 vertices, so the size of the matrix is 5 cross 5, 5 rows and 5 columns. Okay. These are cost values. This is a given problem. So here the traveling salesperson starts at the vertex 1 and visit all other vertices 2, 3, 4, 5. So with minimum cost and return to the same vertex, that is source vertex 1. So that is the given problem. Apply LC branch bounded technique for this problem. Okay. What is the first step in that algorithm? We have to apply row reduction and then column reduction in order to find the reduced cost matrix. So this is a given. Here this is a reduction matrix. How to apply reduction? We have to find out minimum element in this row. So here the minimum element in this row, the minimum element is 10, here the minimum element is 2, and here 2, this row 3 and this row 4. Okay. Sum up all these values, 10 plus 2, 12, 14, 13 plus 4, 21. So minimum value is 10. So subtract this element from this first row. So 20 minus 10. 20 minus 10, what we get? 10. Next 30 minus 10, what we get here? 20. Next 10 minus 10, 0. Next 11 minus 10, we get 1. Apply the same process for remaining rows. So we have to examine, there must at least one 0th element in each row. Okay. Finally we got at least one element in the each row. Next, that is call it as row reduction. So after row, how much we are reducing the cost? 10 plus 2 plus 2 plus 3 plus 4, we get 21. So this is the row reduction after, this is the row wise reduction cost matrix. Next, apply column wise reduction. What is column wise reduction? So we have to examine in this column, what is the minimum element here? 1. In the second column there is a 0th element, so no need to reduce this column. And in the third column the minimum element is 3, and in the fourth column 0 is there, fifth column also 0 is there. So the column reduction is 1 plus 3, that equal to 4. So this is the column reduction. So we have to find the total reduction, 21 plus 4, that equal to 25. This is the total cost. Total cost for the matrix. Total cost for the root node. Okay, this is the root node. So here the solution can be represented by using state space tree. So here 1 is the source for root node. The cost of this node is 25. Okay. That is also represented L, that with L call it as lower bound. This is the lower bound value. Next, U is the upper bound value. Initially we take the value as infinity. Okay. So next, now 1 is call it as a live node. So just we are creating a root node. That means here I equal to 1. Initially the salesperson started at the vertex 1, and what are the other vertices has to be visited? Second, third, fourth and fifth. So there are 4 vertices need to be visited. So let it be I. I is the, what is the meaning of I? I is the nodes which have, I indicates the next node we have to visit. Okay. Here this root node can be expanded by generating its children 2, 3, 4, 5, and these are called, these 4 are called live nodes, and this one becomes, now this one becomes E node. Okay. Now we have to find the cost from 1 to 2, we have to find the cost from 1 to 2, 1 to 3, 1 to 4 and 1 to 5. So first, so there are 4 paths we have to find the cost. Okay. Next we have to calculate the cost for the path from 1 to 2. Consider the path 1 comma 2. Okay. So what we have to do here, we take the reduced cost matrix of root node 1, that is node 1. This is the reduced cost matrix of node 1. Since we are calculating the path from 1 to 2, so 1 is the source vertex here. So we have to start at 1 and visit to other vertex, that is 2. So we have to consider the reduced cost matrix of node 1. This is the reduced cost matrix of node 1. Okay. Next, what we have to do, first we have to make 1 to 2 means first row and second column. First row, second column make infinity. So we get this row and column gets infinity. So that is step 1. Next, and also set 2 comma a, that is j comma I 1 value. What is j value here? This is I and this is j, j value is 2. 2 comma I value is also set to infinity. This is second row, first column value. This is also set to infinity. Okay. This is also set to infinity. Okay. Next, after that apply row reduction and column reduction. Okay. So in this matrix, all the rows have at least 1 0, all the rows have at least 1 0 and all the columns also have at least 1 0. So there is no reduction, so R value is 0. Now we have to find the cost of that node. So C of 2 equal to C of 1 plus A of 1 comma 2 plus R, where C of 1 is the cost of the root node, here the root node is 1 and 2 is the children node. So we are finding the path from 1 to 2, I equal to 1, that is the source vertex, 2 is the other vertex have to visit. So 1 to 2 we are finding the cost. Okay. So that's why C of 1 is called parent node and C of 2 is called child node. And A of 1 2, what is A of 1 2 value? A of 1 2 value is this one, first row second column. Okay. First row second column value is this one, that is 10. Okay. So 25 plus 10 plus 0, what we get? 35. This is the cost of the child node 2. Okay. Next, similarly we have to find the path from 1 comma 3. Consider the path 1 comma 3 and find cost. So we have to make it which row and which column? First row, third column, make it infinity. So we get first row, third column infinity and 3 comma 1 is set to infinity. 3 comma 1, what is 3 comma 1? Third row, first column, it is also set to infinity. Next, after that we have to apply row reduction and column reduction. Okay. After applying row reduction and column reduction, in this row there is no, in this column there is no 0th element, and among these the minimum element is 11, it has 0, this is no need to reduction, and here also 0 0. So only column reduction is applied for this matrix. So what we get, the reduction is 11. Next, C of 3 equal to C of 1 plus A of 1 comma 3 plus R. Okay. C of 1 is cost of root node is 25 and A of 1 3 value. What is A of 1 3 value? In the previous reduced cost matrix of node A, that is root node A, the value is 17. Okay. That is added. So 17 plus 11, that equal to 53. Next, similarly consider path 1 comma 4 and find the cost. Okay, how can we find? Make first row fourth column infinity and 4 comma 1 value is also set to infinity, and then apply reduction, row reduction and column reduction, then we get the value this one, and then find the cost using this formula. Cost of one root node A of 1 4 value, which can be getting from that reduced cost matrix of node A, and R is the reduction. Here the reduction is 0, so we get 25. Okay, so after reduction we got this matrix. Next, similarly we have to find out the path, consider the path 1 comma 5 and find the cost. Apply first, initially make all entries of first row and fifth column as zeros, and 5 comma 1 value is also set to 5 comma 1 means this value is also set to infinity, and then apply row reduction and column reduction on this matrix. Then we get this reduced cost matrix. So here there is no in the first row infinity, no need to check it. Second row, here there is no 0th elements, so the minimum element is 2, third row no need, and fifth row the minimum element is 3. 3 plus 5 we get 2 plus 3 we get 5. So row reduction is applied here, we get 5 row reduction. So column reduction, every element, every column has 0th elements, so there is no need of column reduction, so its value is 0. So the total reduction is 5 plus 0, that equal to 5. Okay. Next, so cost of 5 equal to cost of 1 plus A of 1 comma 4 plus 5, that is 25 plus 1 plus 5, then we get 31. So after finding cost for each children, we have to assign associate cost to its children. Okay. So what is the cost of 2? That is 35. Cost of node 3 is 53, and 4 is 25, and 5 is 31. Among these 4, which one is minimum? 25 is the minimum. So this is call it as, so now this node is expanded by generating its children, that is E node. Then 4 becomes E node, it is expanded by generating 3 children. Why we are here generate only 3 children? Already we visited one source vertex, I equal to 1 here, next I equal to 4 here. What are the remaining vertices need to be visited? Only 3, 2, 3 and 5. Okay. So now the root of the 6, 7, 8 is 4. So we have to examine the paths. What are the paths are? What are the new paths? We have to find the cost. We have to find from 4 to 2, 4 to 3 and 4 to 5. So 4 to 2, 4 to 5 and 4 to 3 and 4 to 5, these are the paths. For these paths we have to find the cost matrix. For this the reduced cost matrix is updated. So in this we have to take the cost of the fourth node. Node for reduced cost matrix we have to consider for this finding the cost of its children. Okay. So this is the cost matrix, reduced cost matrix of node 4. Next, we have to find the cost of the path from 4 comma 2. So next, same process we have to apply. So fourth row and second column, entries make it as infinity. Fourth row and second column make it as infinity, and 2 comma 1 value is also set to infinity. 2 comma 1 means second row first column. Okay, this element is also set to infinity. Okay, after that apply row reduction and column reduction, we get this matrix. Here each and every row and column have at least 0 elements, so that's why we get the reduction 0. Similarly, we have to calculate the cost of node 6, we get 25. Next, find the path cost for the path 4 comma 3. Okay, so we have to consider what is this one. This is the reduced cost matrix of node 4. Okay, node 4 reduced cost matrix, this one. So then what we have to do, make 4 3 means fourth row and this third column make elements infinity, and we have to set 3 comma 1 is also infinity. 3 comma 1 means the third row first column element is also set to infinity, and then apply row reduction and column reduction. Okay, in that what we have to examine, in the first column there is no 0th element, so we have to apply column reduction, that is 11. Second column no need, third one, fourth one, fifth one, so there is no need. So we get the row reduction, column reduction value is 11, and row reduction, first row no need, second row no need, third row has no 0th element, so minimum element is 2, so 2 minus 2 we get 0 here. Okay, 11 minus 11, 0 here. So what is the total reduction? 11 plus 2, that is 13. Okay, so this is the cost of the node 7, that is 50. Next, similarly we have to calculate the cost for the path 4 comma 5. So what we get, the cost values are 28, 50 and 36. Among these three, which one is minimum? 28 is the minimum. Okay, so here again this 6 can be expanded by generating its children 9 and 10. Here now 6 is called E node and 9 and 10 are called live nodes. These are called live nodes. Okay, similarly same process is applied for calculating the cost. Okay, here the cost of node 9 is, we get 52, and the cost of node 10 is 28. So among these two, which one is minimum? 28 is the minimum. So this node can be expanded. Okay, what are the vertices already we have visited? I equal to 1 source vertex, and then 4, and then 2, and then 5. What is the remaining vertex have to be visited? Only 3. So we have to generate only one children here. So that is 11. Similarly, we have to find the cost of this node 11 by considering the path 5 comma 3 here. So what is the reduced cost matrix? We have to consider the reduced cost matrix of node 10. So we have to consider the reduced cost matrix of node 10. This is the reduction matrix of node 10, and the possible path is only one path, that is 5 comma 3. So we have to find the cost for this path 5 comma 3. Next, we have to apply row reduction, column reduction, same process. Then we get the cost value as 25. So this is the final state space tree. So initially we take the upper bound value is infinity and lower bound value is 28. 25, this is the cost of the root or vertex node. Okay, here I equal to 1, here I equal to 1. So this is the final state space tree. So we visited all the nodes, I equal to 4, 2, 5 and then 3. So visited all the nodes, and then what is the cost value here? 28. So all the nodes are visited. Then this 11 is called here answer node. Answer node means the path from root to this leaf node which gives a solution for a given problem. Then this leaf node is called it as answer node. Answer node means which gives a solution, right? So now after getting the answer node, we have to change this upper bound value. What is upper bound value initially? Infinity. So it is updated with 28. Okay. Now compare this upper bound value with the cost of remaining all other nodes. What are all other nodes? Here this is answer nodes. What are remaining live nodes? The live nodes are this one 2, 3, 5, 7, 8, 9. These are called live nodes. So we have to compare the cost value of these nodes with this upper bound value. All the cost values are greater than this upper bound value. So we have to kill this node. Kill this node, this one, and this one, this one, this one, this one. So, only we have these nodes in this graph, sorry, in this state space tree. So, this is the path. So, if the cost is greater than the upper bound value, so we must be killed that nodes. So, all the live nodes are killed and the node 11 is considered as the answer node. So, here the shortest tour of this traveling salesman problem is 1 to 2, 4 to 1 to 4, 4 to 2, 2 to 5, 5 to 3 and 3 to 1. So, we have to sum up its cost values, then we get the minimum cost value is 25. So, this is the solution for this traveling salesman problem. Okay. Okay, thank you.